Alright, hello, my name is Levi and I will be taking you through our redesign of a user interface. Our group chose to redesign a digital programmable thermostat. We felt that this would be a good choice for us because we're very familiar with these digital thermostats. We interact with them daily and we had a good base knowledge of where to start. So there are many human-computer interaction inconsistencies, and we performed a couple of interviews with real-world users to find out their thoughts. Here, if you look at the two digital thermostats we have here, if you look on the left, can't exactly figure out what that is. There's a man in a house and he's carrying something. I can't figure that out. And then there's a volume control, or it looks like a volume control. Here's week 3, not quite sure what that means. Hand pointing to a sun. And left down, right up might not be what someone is used to. So after performing these interviews, we found that there are several pros and cons of current systems. They all take advantage of natural up-down affordances for heat and cool. They have large display to button ratio, but they have limited visibility of the current status, meaning what is it doing right now. There's limited immediate feedback, meaning did it register your input, and there is limited real-world dialogue. Does it speak your language? We found that those were where current systems fail. So the 3 tasks for improvement that our group took on was to create a thermostat that is easy to set a future program, including the time, temperature, and date. One that is able to maintain consistency throughout the day and monitor feedback. And a thermostat that is able to easily return to program settings after you make an adjustment. So we feel that people program thermostats to save electricity and therefore money during the day when they are not at home. And we feel that a better design would be easily programmable and would require less monitoring and attention. And we felt that the way to do that would be to create a design that has appropriate and immediate feedback, that speaks the user's language with as little dialogue as possible while being consistent and efficient. And Ryan will now talk to you about design.
After coming up with the 3 tasks, we created a low-fidelity paper prototype, and we took into consideration what people liked about current thermostat designs and also what they didn't like, and we came to this. Some of the things we kept were a large display and the layout, like most thermostats have some buttons that correspond with, like these boxes, the buttons correspond with what it says there. So we kept that, and we used our prototype to capture data, and after testing we ran into a lot of problems with the paper prototype, so we created an electronic version. Now this is going to be a video of what it would be like to interact with the new electronic PowerPoint version.
So the first iteration of the programming process for our redesigned thermostat interface, the first thing we do from the home screen is we hit program, and that will take us to the program menu. When they create new program, we want our interval to be from 1 p.m. to 5 p.m. So first use the arrow to go up to 1 p.m. We'll hit OK. Once we've selected that, we'll go up to 5 p.m. for our end time. And it will once again display feedback showing the times that we selected for the time period. Then we need to apply that time period to a day. And so for this time period, we want to select Thursday, and we come bold telling us that we selected it, we'll hit OK. We want to apply 72 degrees to this interval, so we'll go up to 72 degrees, hit OK to confirm that. Here's all the information concerning what we think. We can go back if we wanted to edit any of that, but this is good, so we'll hit OK. This is a note saying that there's already an interval there, and we're going to replace it if we click OK. So we'll go ahead and click OK and do that. And this is a pop-up telling us that it's finished, and it'll take us back to the program menu.
Jordan's going to talk to you about the testing phase.
Alright, during testing we found several errors that led us to redo our prototype. And what we did in that process, we had the kind of standard things. We had the informed consent. Then we had a pre-test before they took the test to find out some general information. Then we had them use the paper prototype and interact with it, and we recorded results from that. And then after that, we asked them to create the prototype and compare it to the system that they currently use. And then we had a standard debriefing. Alright, what we found was that there's a cluster of errors in all three tasks. This is just for the first task, divided into 8 different subtasks. And there's a cluster of errors and as well as a markedly larger amount of time taken to do subtask 3. And from what we saw, that really shouldn't have taken any more time than any of the others. And what we ended up concluding was that users wanted to move this part of this is actually a movable part of the prototype. And so is this, they wanted to move that even though they were told there's nothing on the screen that they would be able to move. Just the fact that it was able to be touched and moved on the prototype, even though it was supposed to be operated using the Wizard of Oz method, they still wanted to interact with that instead of that drawn-in buttons. And so that caused a lot of problems and skewed the data quite a bit. So we thought the best improvement we could do was to actually make an electronic prototype, and Brad's going to talk to you about that.
Alright, this is our electronic prototype as you saw in the video. Some of the changes that we made from the paper prototype was the up-down arrows. We changed those to have colors corresponding to red for heat and blue for cooling down. And we changed the interface to be more consistent by asking for confirmations to the OK button instead of buttons on the screen. And another one of the changes is the active and non-active to show whether the program is on or off. And creating pop-up screens instead of having multiple confirmation buttons. And we'll be using the PowerPoint prototype from now on because the paper prototype was too low fidelity and had too many errors, just the prototype itself. And some of the possible changes that we might make is keeping track of multiple time intervals and going back to certain time intervals and editing them. And some of the this is some of the stuff that helped with the prototype.